Good afternoon, class. So in today's video, what I thought I'd do is go over what happens if I've got a bunch of hot water here and a bunch of cold water here. So what I'm going to do is I'm going to take all this hot water, and as we can see, there's a lot of steam coming out of it. I'm going to pour it into this can. Now, hear me out. What do you guys think? What is the steam is coming out quite a bit. There's quite a volume of water coming out of this flask, right?
Yes.
So if I were to pour it in here, would the steam be able to come out as much?
No.
No. So if it fills up, now what's going to happen? You know, is there going to be a little bit of a difference of, like, say, pressure inside of this can? Could be, right? All right, let's try this. And oh no, I still did it wrong. Okay, put it out here. Water. Okay. Sorry, some of the water spilled out over there. And hopefully, even for the camera, you can see the steam is starting to come out of the top of this. So now here's the question: what if I suddenly change the temperature of because the air inside of here is like really, really hot, right? So now the question is, what happens if I put this into a bunch of cold water all at once? What do you think is going to happen? Okay, more steam will come out. Okay.
The thing is going to try and come out like through the stuff.
Oh, okay. Sounds good. Sounds good. Any other ideas? Okay. Crackling noises because of two different energies. All right, I like it. Anything else? Oh, the can is going to get crushed? Whoa, that's a prediction. That's crazy. Yes? Oh, it's going to make a sound? Okay. All right. Shall we find out?
Yeah.
All right, let's do it. 3, 2, 1. Oh, no. Did I need to put... Oh, shucks. All right. Tell you what, let's try this again, and we'll hopefully we'll get that idea. But if not, if nothing else, we'll get a bunch of the steam here, and I'm gonna try this again. But what I want you guys to notice is what happens if nothing else. What happens to what happens to the water level when I put this can in? Okay. Okay, check this out. Oh wait, actually, let me first pour some of that water in because I need some extra room, right? Okay, let's try this. Ready? 3, 2, 1. Okay. Now notice what happens. Do you see how the can is starting the can is kind of pulling the water level lower than it used to be? Wait, why is that? Yeah, because there's a difference in air temperature. The outside air this air in here is really hot. The air over here is really cold. So the air pressure from the outside of this jar is pushing down and going into the can. Because what happens? Because now check this out. As I lift it up, you see there's a little bit of right. Check out how much water is coming out. There's actually a lot more. That was a lot more than what I had actually poured in. If you notice that. So when you have a difference in air temperature, what happens is that the air pressure will force water to move differently because the volume of water is a little bit different. Especially, the volume of water is different when there's a difference in air pressure, or when there's a difference in temperature because of things like Boyle's law, Charles' law, and also the fact that nature does not want to have a vacuum. So if you were to make this very hot and it stayed the same, and it got cold all of a sudden, it would, without the water coming up into the can, it would start to it would have created some kind of vacuum, and that was not acceptable. So the air pressure would have come back up and pushed it back up. So thought I'd show that as an example for everybody. Study hard. I'll see you in the next video.